When dealing with products of tangent and secant, the way you proceed is kind of similar when dealing with products of sines and cosines, but the rules are a little bit different. So let me explain. In this problem here, we happen to have an odd power on the tangent and an odd power on the secant. And it's important that they are both odd for the following trick to work. All right, so when you have this product of tangent and secant, and they both happen to be odd powers, the trick is to take one of both of those and stick it out there on the right. So, I'm sorry, I'm taking out one of the tangents, so I'll have a tangent squared, a secant squared, and then I have and I'll write it as secant times tangent. And the reason I write it like that is because that's the derivative of secant. Okay, so let me emphasize that since I have secant tangent, all right, that's the derivative of secant, so I want just secants. That's all I want. And in particular, I need to get rid of this tangent squared thing. Now, if you don't remember what the formula is for tangent squared, what that trig identity involving tangent squared is, and I sometimes have trouble remembering it myself, so I could just take the one I do remember, sine squared plus cosine squared equals 1, and then I can just divide both sides by, I want to get a tangent, so I'll have to divide by cosine squared. And sine squared divided by cosine squared is tangent squared, plus, that's a 1, is equal to secant squared of theta. And if I want to replace tangent with something, I can solve for tangent to get secant squared minus 1. Okay, so there is my scratch work to find what's important, which is this formula. Tangent squared is secant squared minus 1. So I'll make that replacement. Tangent squared gets replaced with secant squared minus 1 times secant squared times secant tangent. All right, and so since I have right here, I have the derivative of secant, I can let u equal secant. So that my du is secant tangent d theta. And that's exactly what I've got right here. So when I plug everything in, I get secant squared is u squared minus 1, secant squared is still u squared, and all of this stuff becomes just plain old du. Multiply out that u squared, get u to the fourth minus u squared du becomes 1/5 u to the fifth minus 1/3 u to the third plus c. But we have to remember that's not the answer. It's not the answer because we need to put it back in terms of theta, the variable that we were originally talking about. So I'll just replace all my u's with thetas, secant thetas, excuse me. So that's secant fifth theta minus 1/3 secant cubed theta plus c. Perfect. There is my final answer. Let's do one more. Okay. So in this case, they are not both odd. The trick I just described won't work. In this case, however, we do have some good news. Even though they aren't both odd, we were lucky enough to get an even power for secant. Doesn't matter what that is. All right, that could be anything on that tangent there. But what's important is that the secant's power is even. All right, why is that important? Well, what it allows us to do is take two of those secants and bring them out to the side. So I'm taking out two of the secants, leaving two. All right, and here's the two on the side. And again, the trick is always about noticing that, hey, I've got the derivative of a trig function. Since this, it has the derivative of tangent, I want to have only tangents in here. All right, to get that derivative of tangent there. And to do that, I need to get rid of this secant squared. Well, just a moment ago, we said that secant squared, we said that tangent squared, in fact, I'll show you how to rederive it. Sine squared plus cosine squared is 1. And what we did is we divided both sides by cosine squared, leaving us with secant squared of theta is tangent squared of theta plus 1. And so there's our formula. So we'll take all this up here and replace secant squared with tangent squared plus 1 times tangent to the 5th. There's no thetas, there's x's in the problem. That's no problem though, I'll just have to replace that with my x. All right, sorry about that. Having an issue. There we go. So there we have, oh, not dx though, because we still have from way up here, secant squared x dx. Okay, so that's all well and good. Now what are we going to do? We'll do the same thing we've been doing, only instead, because we have this derivative of tangent up here, right here, that's the derivative of tangent, I'll let u equal tangent of x. My du becomes exactly what I wanted, secant squared x dx. So all that on the right there will just become a du. And everything over here on the left gets replaced with u's. U squared plus 1, u to the 5th, and then again, all this stuff becomes du. I'll multiply out that u to the 5th. And that gets me 1/8 u to the 8th, 1/6 u to the 6th plus c. And all my u's are actually tangents. Right here we see everything that has a u is really tangent. And that wraps it up.